subtopic 8.4 Interference of reflected light in thin films. There are 5 learning outcomes under this subtopic. The first one is identify the occurrence of phase change upon reflection. The second one is explain with the aid of diagram the interference of light in thin films at normal incidence. Use the following equation for constructive interference and destructive interference, but for the case of reflected light with no phase difference, non-reflecting coating. Use the following equation for constructive interference and destructive interference for the case of reflected light of phase difference pi radian reflecting coating. And also, the last learning outcome for this subtopic is explain the application of thin film, example, solar panel or glass tin. Reflection and phase change. The reflected wave undergoes a 180-degree phase change when refractive index of medium 1 is lower than refractive index of medium 2. So, it undergoes a 180-degree phase change or pi radian phase change. So now, as you can see in figure A, there are two medium 1 and medium 2. For example, the refractive index of medium 1 is 1 and for refractive index for medium 2 is 1.33. As you can see, the incident wave, it is positive wave, and then the reflected wave is negative wave, or the incident wave it crest and the reflected wave is true. So, what can you say about this situation? There are 180-degree phase change, as you can see here. So, a light wave undergoes a phase change if it reflects from a boundary of medium with lower refractive index to a medium with higher refractive index. So as you can see, medium 1, the refractive index is 1, and medium 2, the refractive index is 1.33. So that's why there are phase change. Okay, to make it more clearer, I'll draw a diagram. So you have two medium. For example, you have medium 1 with refractive index of 1 and medium 2 with refractive index of 1.33. Okay, let's say your incident wave is positive wave, then negative wave. And then this is your incident wave. Your reflected wave, it will become positive then negative. Why? Because there are 180-degree phase change. As you can see, because the refractive index of medium 1 is lower than refractive index of medium 2. That's why there are 180-degree or pi radian phase change. So, phase changes increase the path length by lambda over 2. Okay, one more thing to make you understand better about this concept. When there are phase change, you can imagine this analogy. So 1, the value is lower compared to 1.33. So we will assume this value as poor. We will assume 1 as poor, and then 1.33 as a rich. So as you can see, the refractive index comes with positive then negative. So as we know, the refractive index for medium 2 is 1.33, higher than 1.1 than the refractive index of medium 1, which is 1. So of course, you don't want to be poor, you want it to be rich. That's why you need to change. So when you change, you will become rich. That's the analogy that you can use. So instead of being poor, you want it to be rich. That's why if you want to be rich, you need to change. That's why you change. So when you change, means that you have 180-degree phase change. But there is no phase change when refractive index of medium 1 is higher than refractive index of medium 2. Remember, no phase change when refractive index of medium 1 is higher than refractive index of medium 2. So as you can see in figure B, we have medium 1 and we also have medium 2. For example, the refractive index for medium 1 is 1.33 and refractive index for medium 2 is 1. So as you can see, the incident wave is positive wave and the reflected wave is positive wave as well. So there are no phase change. So there are no phase change when medium 1 is higher than medium 2, or a light wave will not undergo a phase change if it reflects from a boundary at medium with higher refractive index to a medium of lower refractive index. So no phase change. Okay, to make it more clearer, I'll draw a diagram for you. So you have two medium 1 and medium 2. For example, medium 1, the refractive index is 1.33 and medium 2, the refractive index is 1.00. So for example, the incident wave is negative than positive. So this is the incident wave, and the reflected wave will become also positive than negative. So this is the reflected wave. As you can see now, we can use the analogy, the same analogy as I used before. So 1.33, the value is higher compared to 1.00. So when it is higher, this one is rich and this one is poor. So of course, you are rich now, you don't want to become poor. So that's why you don't want to change. So when you don't want to change, you will remain the same, which is you will remain rich. You don't want to become poor. So that's the analogy you can use. The occurrence of phase change upon reflection. Okay, let's say the light wave travels from medium 1 to medium 2. So upper is medium 1 and below is medium 2. So for medium 1, you will have refractive index of medium 1 and refractive index of medium 2. So the reflection is occur at the boundary of medium. So this is the boundary of medium. So reflection from lower to higher refractive index will undergo a phase change of 180 degree pi radian with path difference of lambda over 2. So okay, for example, if your refractive index for medium 1 is 1 and your refractive index for medium 2 is 1.33. Remember the analogy I told you? So let's say for refractive index for medium 1 is poor and refractive index for medium 2 is rich. So of course, from poor you wanted to become rich. So if you wanted to become rich, you must change. So if you must change, the analogy is the same. You must undergo, the reflected ray undergoes a phase change of 180 degree when the reflection is from lower to higher refractive index. Okay, that's for the case of lower to higher refractive index. What about reflection from higher to lower refractive index? Okay, for example, your refractive index for medium 1 is 1.33 and your refractive index for medium 2 is 1. So now let's use the analogy. Which one is rich? Which one is poor? So yes, refractive index of medium 1 is rich and refractive index of medium 2 is poor. So from rich, do you want to become poor? Of course you don't want. So if you don't want to become poor, there are no phase change. Same goes to the reflection. So it's the reflection from higher to lower refractive index. There are no phase change. When there are no phase change, no path difference. Do you ever wonder what makes soap bubble and thin layer of oil floating on water? Do you ever wonder? The answer is the thin film of the water makes soap bubble for soap bubble situation. These two are examples of thin film interference that we can see in our daily life. Okay, as you can see, this is the soap bubble. Wave that reflects from object at different location can interfere with one another just the light pass through double slits. As you can see, you often see a bright bands of color when light reflects from a soap bubble or form a thin layer of oil floating on water. But how? So now we are going to learn how does this happen. So as you can see from the diagram, there are three medium, which is air with refractive index of 1, and water or glass is thin film. So I'll use water in this example. The refractive index of water is 1.33, and air, the third medium is air. The refractive index of air is 1.00. So in this diagram, I will consider only ray 1 and ray 2. Okay, this is ray 1. Okay, my question is, ray 1, does it undergoes phase change or not? Okay, actually, ray 1 undergoes a phase change because it reflects from a boundary at which the index of refraction increases. So as you can see, the index of refraction increases because N1 is 1 and the thin film is 1.33, the refractive index. Now we can see that the refractive index of thin film is higher than refractive index of medium 1. That's why ray 1 undergoes phase change. Undergoes phase change. Okay, now let's look at ray 2. So this is ray 2. Okay, does ray 2 undergoes phase change or do not undergo phase change? Ray 2 does not undergo phase change because it reflects from a boundary at which the index of refraction decreases. So it decreases. So as you can see, N equals to 1.33 and N2 equals to 1.00. So refractive index for water or thin film is higher than refractive index for air. That's why it does not undergo any phase change. So there are two types of interference in thin film. So when we are talking about thin film, we must take into consider its thickness T and also the refractive index of the interference. Okay, so the two types of interference in thin film are in-phase interference, which the case are refractive index of thin film is higher than refractive index of medium 1 but lower than refractive index of medium 2. For antiphase interference, there are two cases, which are refractive index of thin film is lower than refractive index of medium 1 and lower than refractive index of medium 2. And another case is refractive index of thin film is higher than refractive index of medium 1 and also higher than refractive index of medium 2. So now let's look at these two types of interference in thin film. In-phase interference, where the refractive index of thin film is higher than refractive index of medium 1 and is lower than refractive index of medium 2. So light is incident normally on the thin film. Then it partially reflected at A and B on the thin film as ray 1 and ray 2. So will ray 1 undergoes a phase change? Okay, let's have a look. Okay, for example, if the incident wave is positive, negative, what will happen to ray 1? Will it undergo phase change or not? Yes, it will undergo phase change. So it will become positive, negative. Why it undergoes phase change? Because it reflects from a boundary at which the index of refraction increases. So as we know, refractive index of medium 1 is 1, refractive index of thin film is 1.4, so it increases. So that's why refractive index of thin film is higher than refractive index of medium 1. So now, if you're using the analogy, you are poor. You wanted to becoming rich, so you need to change. So what we can say that the ray 1 must undergo phase change of pi radian of path difference of lambda over 2. What about ray 2? Will it undergo phase change or not? Okay, let's have a look. Okay, now so incident wave is positive, negative. What about the reflected wave? Yes, the reflected wave will undergo phase change as well because it reflects from a boundary at which the index of refraction increases. So it increases, the refractive index of thin film is 1.4 and refractive index of medium 2 is 1.52. It increases. So medium 2 refractive index is higher than refractive index of thin film. So of course you want it to become rich. So you need to change. That's the analogy. So both of these rays will overlap either constructively or destructively. In this case, both of these rays will overlap constructively. So if it's interfere constructively, then the equation is 2nt equals to m lambda. So if it's interfere destructively, then the equation is 2nt equals to m plus half lambda. Antiphase interference, where the refractive index for thin film is lower than refractive index of medium 1 and is lower than refractive index of medium 2. So the light is incident normally on the thin film. Then the light is partially reflected at A and B on the thin film as ray 1 and ray 2. But the question is, does ray 1 and ray 2 undergo phase change or do not undergo phase change? Okay, let's have a look at this diagram. As we know, the refractive index for medium 1 is 1.52. Refractive index for the thin film is 1 and the refractive index for medium 2 is 1.52 as well. Okay, now let's see whether ray 1 undergoes a phase change or not. Okay, for example, the incident wave is positive, negative. Okay, so now the refractive index is 1.52 and the refractive index for thin film is 1. Does it undergo phase change or not? No, it does not undergo phase change because it reflects from a boundary at which the index of refraction increases. So it seems like N1 is higher, refractive index of medium 1 is higher than refractive index of thin film. That's why there are no phase change. So like I said before, as we know, the refractive index of medium 1 is 1.52. Refractive index for thin film is 1. Remember the analogy rich and poor? So now you are rich. You don't want to become poor, right? So like, you know, the refractive index of medium 1 is 1.52. The value is higher than refractive index of thin film, which is 1. So you wanted to remain becoming rich. You don't want it to become poor. So you cannot change. So there are no phase change for ray 1. What about ray 2? Okay, let's say the ray 2, the incident wave is positive, negative. And then, but it reflected back. Is there any phase change or not? Yes, they are phase change. It will become negative, positive. Why they are phase change? Because it reflects at a boundary at which the index of refraction increases. As we know, N2 is higher, refractive index of medium 2 is higher than refractive index of thin film. That's why it undergoes phase change. So now you are poor, you are 1. The value is 1. You want it to become rich, which is 1.52, the analogy. So you need to change. So if you need to change, there must be a phase change. So that's why ray 2 undergoes a phase change. So when you plus these two waves, you will get destructive interference. So as you can see, ray 1, no phase change and no phase difference. But for ray 2, undergo a phase change of pi radian or 180 degree with path difference of lambda over 2 and travel at extra distance of 2t. And both rays will overlap either constructively or destructively. In this case, the rays overlap destructively. Interfere constructively when the path difference, the equation is 2nt equals to m plus half lambda, and interfere destructively, the equation is 2nt equals to m lambda. Difference where refractive index of thin film is higher than refractive index of medium 1 and is higher than refractive index of medium 2. So as usual, light is incident normally on the thin film, and the light is partially reflected at A and B on the thin film as ray 1 and ray 2. But does ray 1 and ray 2 undergo phase change or not? Okay, let's have a look. And we know refractive index for medium 1 is 1, refractive index for thin film is 1.33, and refractive index for medium 2 is 1. Okay, now let's look for ray 1. Okay, for example, the incident wave is positive, negative. What about the reflected wave? Does it have a phase change or not? Yes, it undergoes a phase change because why? Why does it undergo a phase change? Because it reflects from a boundary at which the index of refraction increases. So it increases from 1 to 1.33. So refractive index of thin film is higher than refractive index of medium 1. That's why it has phase change. So remember the analogy. Okay, now you are poor, you wanted to become rich, so you need to change. Same goes to this situation. That's why there are phase change. So for ray 1 undergoes a phase change of pi radian with path difference of lambda over 2. What about ray 2? Does it undergo a phase change or not? Okay, let's have a look. Okay, now, for example, the incident wave is positive, negative. What about the reflected wave for ray B? It will still remain as positive, negative. Why? Because it does not undergo a phase change, because it reflects from a boundary at which the index of refraction decreases. Can you see decreases? 1.33 to 1 is decreases. So it means refractive index of medium 2 is higher than refractive index of thin film. So now you are rich. You don't want to become poor, right? So if you don't want to become poor, you need to remain becoming rich. So you no need to change. That's why same goes this analogy you can apply. Then same goes to this situation. No phase change, no phase difference. So both rays will overlap, interfere either constructively or destructively. In this situation, the ray will overlap destructively. So destructive interference. So if interfere constructively, the equation is 2nt equals to m plus half lambda. If it's interfere destructively, it is 2nt equals to m lambda. Application of thin film. One of the applications of thin film is metal roof panel with thin film photovoltaic PV roof panel. Thin film on solar panel is characterized as its high reflect, long-term performance and electrical resistance. Its unique highlight reflect property could enhance efficiency on PV module. So PV is photovoltaic. And then almost increases 2% yield value and solve the most common production problem in the glass to glass assembly. No delamination, no spilling, white. Summary for interference in thin film. So you can use IC madam. So I is for in phase. C is for constructive. M is for M lambda. So in phase constructive interference for in phase is 2nt equals to M lambda. So you can remember by IC madam. So I is in phase, C is constructive, M is M lambda. What about the destructive interference for in phase? It's going to be the opposite equation for constructive interference for in phase, which is 2nt equals to M plus half lambda. What about A? ADM. So A is antiphase. D is destructive. A is antiphase. D is destructive. M is M lambda. So for destructive interference for antiphase is 2nt equals to M lambda. What about constructive interference for antiphase? It's the opposite equation of destructive interference, which is 2nt equals to M plus half lambda.